In the profound stillness of the year 2044, a microscopic pulse of light-speed data radiated outward from the terrestrial cradle, a silent command cutting through the electromagnetic static of the inner solar system. This signal, a sequence of binary logic forged in the labs of the Interstellar Ion Integrated Project, sought a single destination, the 3I-ATLAS probe. At this moment, the craft existed as a silver needle suspended in the velvet dark, the most sophisticated scout ever birthed by human ingenuity, coasting on the momentum of its launch toward the gas giants. It was a masterpiece of carbon lattice frames and gold filigreed sensors, designed to withstand the crushing radiation of the Jovian system. But as the command reached its receiver, the mission's original purpose evaporated, replaced by a trajectory that defied every established protocol of planetary exploration. The probe's central processing unit ingested the new coordinates. There was no hesitation, no mechanical doubt. The logic of the machine accepted the mandate to ignore the swirling amber-hued storms of Jupiter, a world of 1.89 times 10 to the power of 27 kilograms that had been pulling at the craft with its immense gravitational hunger. Instead of banking into the planet's deep gravity well to steal its velocity, the 3I-ATLAS began a slow, deliberate pivot. Its reaction wheels spun with silent precision, turning the craft's inquisitive sensors away from the Great Red Spot and toward a patch of absolute unyielding nothingness. This was a coordinate where no star burned brightly, where no planet exerted its influence, and where the maps of human astronomers insisted only a vacuum resided. Deep within the heart of the propulsion module, the ignition sequence for the Hall effect thrusters commenced. There was no thunderous roar, no violent eruption of chemical flame to mark this new era of the journey. Instead, a stream of xenon gas was fed into a ceramic chamber, where it was bombarded by high-energy electrons. The gas transformed into a glowing plasma, a spectral blue aura that shimmered at the base of the craft. Accelerated by a powerful electric field, the ions were expelled into the void at staggering velocities. The resulting thrust was subtle, a constant, relentless pressure of 0.05 meters per second squared. But in the frictionless theatre of space, this whisper of force was transformative. The 3I-ATLAS began to climb a mountain of its own making, pushing against the very fabric of the vacuum to reach for 1% of the speed of light. As the acceleration took hold, the craft began its departure from the familiar solar plane. For billions of years, the planets had remained locked in a flat, spinning disk around the sun, a celestial record player of dust and rock. The 3I-ATLAS was now breaking that ancient symmetry. It rose above the ecliptic, looking down upon the solar system as if viewing a receding island from the deck of a departing ship. The familiar landmarks of the night sky began to shift in their relative positions. The sun, once a dominant and life-giving furnace, began to shrink. Its warmth faded into a memory, replaced by the biting cold of the deep. The star that had nurtured every ancestor of the probe's creators was reduced to a sharp, distant needle of light, a singular point of brilliance that no longer provided a sense of direction. The maps that had guided human voyagers for centuries, from the first mariners following the North Star to the engineers of the 20th century, ceased to provide guidance. The probe was entering a realm where the concept of up or down was rendered meaningless by the scale of the surrounding emptiness. The sensors, calibrated to detect the magnetic signatures of moons and the thermal radiation of planetary atmospheres, now stared into a void so deep it seemed to swallow the very light that attempted to traverse it. The primary objective was no longer a target of rock or gas, but the absence of a target itself. The mission had become a direct confrontation with the limits of perception, a journey into the dark to see if the dark would blink first. The silence that enveloped the 3I-ATLAS was absolute. Behind it, the inner worlds continued their clockwork orbits, oblivious to the metal interloper that had abandoned their company. Ahead lay the great interstellar expanse, a territory that had remained a mystery since the first eyes looked upward and wondered. The craft moved with a new kind of purpose, one born of curiosity rather than conquest. It was a ghost ship of the 21st century, a vessel of glass and metal carrying the collective intent of a species that had finally decided to look into the shadows. The departure from the solar plane was not merely a change in flight path, it was a severance of the umbilical cord that tied humanity to the Sun. The 3I-ATLAS was now a citizen of the galaxy at large, a lonely observer drifting into a coordinate where the maps ended and the true story of the universe began. In this transition, the tone of the mission shifted from one of data collection to one of existential inquiry. The probe was no longer seeking to confirm what was known, but to witness what was hidden. Every kilometre gained was a step further into a reality that did not care if it was understood. The blue glow of the ion engine remained the only constant, a small, defiant spark in a cathedral of shadow, pushing the 3I-ATLAS toward a destiny that lay far beyond the reach of the amber clouds it had so boldly left behind. The interior of the 3I-ATLAS is a testament to the refinement of human ambition, a sanctuary of stillness where the frantic energy of the industrial age has been distilled into a silent, elegant flow of subatomic particles. At the core of this vessel lies the interstellar ion-integrated propulsion system, a marvel of engineering that operates far beyond the crude, explosive requirements of the 20th century. In those earlier eras of exploration, humanity relied upon the violent combustion of liquid oxygen and refined kerosene, a brute force method that consumed thousands of tons of fuel in a matter of minutes to escape the heavy hand of Earth's gravity. Those rockets were monuments to fire and noise, brief and terrifying bursts of energy that left the craft coasting for decades on the meagre momentum of a single explosion. The 3I-ATLAS, however, is a creature of a different philosophy. It does not explode, it breathes. The heart of this system is the Hall effect thruster, a device that translates electrical power into kinetic motion with surgical precision. Within the thruster's circular ceramic channel, a supply of xenon, a heavy, noble gas, is released with meticulous care. Xenon is the ideal propellant for such a journey. It is chemically inert, dense, and easily manipulated by electromagnetic forces. As the gas enters the chamber, it is met by a swarm of high-energy electrons, which have been trapped in a powerful magnetic field. This field creates what is known as a Hall current, a swirling ring of electrons that act as a gauntlet for the incoming gas. When the xenon atoms collide with these electrons, they are stripped of their own outer electrons, transforming from a neutral gas into a stream of positively charged ions. This is the moment where the machine exerts its will upon the vacuum. A potent electric field established between an internal anode and an external cathode seizes these newly formed ions. Because they carry a positive charge, the ions are repelled by the anode and attracted toward the exit of the thruster with incredible intensity. They are accelerated to speeds that would have been unthinkable to the engineers of the Apollo era, streaming out into the void at tens of thousands of meters per second. This exhaust is not a flame, but a plasma, a fourth state of matter that glows with a ghostly ethereal blue light. This luminescence is the only sign of the incredible forces at work, a soft cerulean halo that marks the boundary between the human-made object and the infinite dark. The acceleration produced by this process is deceptively modest, 0.05 meters per second squared. To a terrestrial observer, this would feel like almost nothing, a pressure so slight it would barely stir a leaf. Yet, in the absence of friction and the persistent drag of an atmosphere, this tiny force is a compounding miracle of mathematics. Every second that passes, the 3I-ATLAS moves 0.05 meters per second, faster than it did the second before. It is a relentless, unceasing climb. While the chemical rockets of the past were sprinters that exhausted themselves in the first few kilometers of the race, the 3I-ATLAS is a marathon runner whose pace only increases as the miles accumulate. The objective of this steady accumulation of speed is to reach 1% of the speed of light, a velocity of approximately 3,000 kilometers per second. At such speeds, the probe would be able to cross the distance between the Earth and the Moon in just over 2 minutes. This target is not merely a number on a navigation chart, it is the threshold required to make interstellar distances tangible within a human lifetime. The journey to this velocity requires years of constant thrust, a testament to the endurance of the craft's internal power systems. The electricity required to maintain the Hall effect thruster is provided by a high-efficiency nuclear thermal generator, which sits at the opposite end of the craft, shielded by meters of dense tungsten and lead. This generator converts the heat of decaying isotopes into the electrical lifeblood that feeds the ion engine, ensuring that the blue glow remains steady even as the sun's light fades to a mere glimmer. As the 3I-ATLAS pushes deeper into the abyss, the blue light of the thruster becomes the only source of heat and radiation in an environment that is rapidly approaching absolute zero. The exterior hull of the probe, once warmed by the gold-white radiance of the sun, is now a landscape of frost and shadow. Inside the pressurized conduits, the xenon flows like a cold silver ghost, waiting for its turn to be electrified and cast out into the void. The machine has become a closed loop of logic and light, a self-contained island of order in a universe that is increasingly chaotic and cold. This modern efficiency represents a fundamental shift in how the species views the act of travel. We're no longer throwing stones at the stars, we're weaving ourselves into the electromagnetic fabric of the cosmos. The 3I-ATLAS does not fight against the vacuum, it utilizes the fundamental laws of physics to glide through it. The silence of the engine is a reflection of this harmony. There is no vibration, no shuddering of the airframe, no roar of escaping gases. There is only the hum of the magnetic coils and the steady blue pulse of the plasma, pushing the probe toward a speed that will eventually allow it to outrun the very history of its creators. In this growing expanse of cold, the craft is a lonely glowing ember, fueled by the same curiosity that once led humans to master the flame, now refined into a beam of ions cutting a path through the eternal night. To the left of the probe's trajectory, the King of Planets looms as a gargantuan obstacle of gas and gravity, a world so massive it anchors the celestial mechanics of the entire outer solar system. Jupiter is not merely a planet, it is a colossus of 1.89 times 10 to the power of 27 kilograms, a sphere of compressed hydrogen and helium that bends the very geometry of space-time around itself. For decades, this immense mass has served as the ultimate filling station for human ambition. In the traditional narrative of spaceflight, Jupiter is the great accelerator, a gravitational catapult that allows our fragile machines to leap across the staggering distances of the outer dark. The missions of the past, such as Voyager 1 and Voyager 2, launched in 1977, or the Cassini-Huygens mission of 1997, were designed to fall into this planetary trap with surgical precision. They sought the free gift of the gravity assist, a thermodynamic windfall that allowed them to reach the edges of the solar system without carrying impossible quantities of fuel. The physics of this maneuver is a delicate exchange of momentum, a cosmic dance where the craft enters the planet's sphere of gravitational influence from a specific angle. As the probe falls toward the planet, it accelerates under the pull of that 1.89 times 10 to the power of 27 kilogram mass, but the true magic happens through the exchange of orbital energy. By approaching from behind the planet's direction of travel, the spacecraft effectively steals a microscopic fraction of Jupiter's own orbital velocity around the Sun. The planet, slowed by an imperceptible degree, flings the craft forward with a massive increase in speed relative to the solar center. It is a beautiful, calculated theft, a way for biological creatures to use the momentum of giants to bridge the gap between stars. Without these assists, the early pioneers of the 20th century would have been stranded in the inner solar system, their chemical rockets exhausted long before they could reach the heliopause. However, the 3I-ATLAS represents a fundamental break from this scripted cosmic ballet. As it approaches the orbital neighborhood of the gas giant, the probe does not tilt its nose toward the amber-swirled horizon. It does not seek the acceleration of the Jovian well. Instead, it maintains its lonely, straight-line vector, steering wide of the planet's influence. This decision is a profound statement of mechanical independence. By bypassing the gravity assist, the 3I-ATLAS must rely entirely on its internal power, its own ion-integrated heart, to generate every meter per second of its velocity. This choice highlights the sheer, grueling difficulty of navigating the vacuum when one refuses the assistance of the giants. It is the difference between a sailing ship that must follow the prevailing winds and a modern nuclear vessel that carves its own path through the waves regardless of the current. To move against the grain of celestial mechanics in this way is to challenge the very laws that have governed spaceflight since its inception. The probe becomes a lone actor on a stage where every other movement is dictated by the heavy hand of gravity. While the planets and moons follow their predetermined ellipses, locked in a multi-billion-year cycle of falling and spinning, the 3I-ATLAS moves with a linear artificial intent. It ignores the siren call of the deep gravity well, a pit in space-time that would have added kilometers per second to its speed in exchange for a change in direction. By refusing this trade, the craft preserves its chosen heading toward the absolute dark, but it pays for this autonomy with the relentless consumption of its xenon stores. Every moment of its journey is a battle against the natural tendency of the solar system to pull objects back into its sun-centered embrace. This defiance creates a sense of profound isolation. As Jupiter recedes into the distance, its great red spot, a storm larger than the Earth itself, appears as a fading eye watching the probe depart into the emptiness. The massive radiation belts of the planet, which would have fried the electronics of a lesser craft, are avoided entirely. But so too is the protection of the planet's magnetic shield. The 3I-ATLAS is truly alone now, a silver speck moving through a territory where no human-made object has ever travelled without a gravitational push. It is a test of the Hall effect thrusters and the nuclear generators, a test of whether human technology has finally reached a point where it can dictate its own terms to the universe. The rejection of the Jovian catapult signifies a transition from being a passenger of the solar system to being a navigator of the galaxy. The probe is no longer a ball being tossed from one planetary hand to another. It is a self-propelled entity, a sovereign vessel in the interstellar sea. The difficulty of this path cannot be overstated. Without the free energy of the gravity assist, the climb to 1% of light speed is a slow, agonizing process that requires years of uninterrupted thrust. It is a journey of endurance, where the steady blue glow of the ion exhaust must overcome the lingering pull of the sun and the indifference of the void. In this silence, the 3I-ATLAS continues its ascent, a tiny, defiant spark moving against the ancient clockwork of the stars, proving that the shortest path to the unknown is not always the one paved by the gravity of giants. The 3I-ATLAS now drifts into a region of space where the titanic tug-of-war between the Sun and Jupiter reaches a haunting, silent stalemate. This is the fourth Lagrange point, a gravitational harbour situated 60 degrees ahead of the gas giant in its sweeping orbital path. In this invisible pocket of equilibrium, the laws of physics have created a natural collection point for the primordial debris of the early solar system. Here, the Trojan asteroids reside, a census of ghosts numbering more than 7,000 identified bodies. They are the eternal companions of the King of Planets, locked into a permanent dance that began 4.6 billion years ago, when the planets were still coalescing from a swirling disk of hot dust and incandescent gas. These rocks are the discarded fragments of creation, the material that was never permitted to join the ranks of the major worlds, condemned instead to circle the sun in a perpetual state of frozen arrest. To a mind fed on the frantic fantasies of cinematic asteroid belts, this region might be expected to appear as a dense thicket of tumbling stone, a chaotic graveyard where collisions are frequent and the passage is a treacherous gauntlet. The reality encountered by the 3I-ATLAS, however, is far more desolate and profoundly vast. As the probe traverses this gravitational trap, it finds not a crowded field of debris, but an overwhelming expanse of nothingness. The 7,000 Trojans are not huddling together. They are scattered across a volume of space so immense that the human mind struggles to scale it. Each body is separated from its nearest neighbour by millions of kilometres of vacuum. One could fly through the heart of this populated region 1,000 times and never lay eyes on a single rock. The density of this field is so low that for the probe, the greatest challenge is not avoiding a collision, but acknowledging the sheer loneliness of these ancient sentinels. The 3I-ATLAS moves through this invisible architecture with a precision born of cold mathematical logic. Its sensors, unblinking and tireless, scan the darkness for the faint thermal signatures of these distant wanderers. Occasionally, the craft passes within a few million kilometres of a specific Trojan, perhaps a mountain-sized fragment of carbonaceous rock, dark as soot and covered in a fine powder of ancient regolith. These asteroids are time capsules, their surfaces scarred by the impacts of micrometeorites over eons, their chemical compositions unchanged since the dawn of the solar system. They contain complex organic molecules and volatile ices that have remained frozen since the Sun first ignited its nuclear fire. To see them is to look back into the prehistory of our own world, to touch the raw materials from which the Earth and its oceans were eventually fashioned. The navigation of this region requires the probe to weave through a subtle, undulating terrain of gravity. Even without the direct overpowering pull of Jupiter, the collective mass of the Trojans and the delicate balance of the Lagrange point create a landscape of highs and lows in the fabric of space-time. The 3I-ATLAS does not merely coast, it performs minute adjustments to its trajectory, its reaction wheels spinning with surgical exactitude to ensure it remains on its chosen path toward the outer dark. It is a silent, graceful passage, a lone needle of human intent threading through a graveyard of forgotten worlds. The probe's refusal to use the gravity of the giants means it must respect the subtle influence of these smaller bodies, treating each million-kilometre gap as a corridor to be navigated with the utmost care. In this region, the sense of isolation becomes a physical weight. The Sun is now a distant, brilliant spark, providing light but no longer offering the comfort of warmth. The Trojan asteroids, despite their numbers, offer no companionship. They are merely dark shapes in a darker sea, indifferent to the passage of the silver interloper. They are the failed bits of the solar system, the remnants of a process that favoured the large and the lucky. As the 3I-ATLAS leaves the fourth Lagrange point behind, it leaves these ancient rocks to their eternal silent vigil. The probe is moving faster now, its ion engine continuing its relentless blue pulse, pushing it beyond the reach of the planetary guardians. The architecture of the inner solar system is fading, and the true void, the vast unmapped territory between the stars, begins to exert its pull. The encounter with the Trojans has served as a final reminder of the scale of the cosmos. Even in the crowded places, the dominant feature of the universe is the silence of the gap. The departure from the Jovian neighbourhood is marked not by a visual change, but by a profound shift in the invisible landscape of the electromagnetic spectrum. For weeks, the 3I-ATLAS has been buffeted by the screaming radio frequency interference of Jupiter's magnetosphere, a structure of such monumental scale that it dwarfs any other planetary feature in the solar system. This magnetic field, 20,000 times stronger than the one protecting the Earth, acts as a colossal particle accelerator, trapping electrons and ions in a lethal high-energy dance. To the probe's sensitive antennae, Jupiter has been a roaring furnace of noise, a chaotic storm of decometric radiation that drowned out the subtle signatures of the wider universe. But as the distance between the craft and the gas giant stretches into the hundreds of millions of kilometres, this cacophony begins to fade. The probe crosses the magnetopause, the outer boundary where the planetary field finally yields to the pressure of the solar wind. It is a transition of startling clarity. One moment, the instruments are saturated by the sonorous thrum of trapped plasma. The next, they emerge into a realm of pristine, electromagnetic stillness. This is the true silence of the deep. Away from the interference of the Sun's larger children, the environment becomes a vacuum in more than just the physical sense. It becomes a laboratory of absolute quiet. In this sanctuary of shadow, the 3I-ATLAS prepares to listen to the whispers of the cosmos that have remained hidden since the dawn of time. On board the craft, the cryogenic cooling systems engage with a soft, rhythmic pulse, lowering the temperature of the sensitive calorimeters to within a fraction of a degree of absolute zero. These instruments are masterpieces of thermal engineering, designed to measure the energy of single subatomic particles or the faint infrared glow of distant cooling objects. In the noisy regions of the inner solar system, such measurements would be impossible, as the ambient heat and radiation would overwhelm the sensors, like a shout drowning out a sigh. But here, in the shadow of the outer dark, the calorimeters reach a state of perfect equilibrium. They become so sensitive that the impact of a single cosmic ray or the passage of a lone neutrino is recorded with the precision of a master clock. The clarity is immediate and overwhelming. the sensors begin to map the cosmic microwave background radiation, the fading afterglow of the Big Bang itself, with a resolution that terrestrial telescopes could only dream of. Free from the distortion of planetary atmospheres and the blinding glare of the sun's magnetosphere, the probe perceives the universe as it truly is, a vast interconnected web of energy and matter. It hears the distant rhythmic pulses of pulsars spinning in the hearts of faraway nebulae, their signals arriving as clean mathematical ticks in the dark. It detects the faint cooling signatures of supernova remnants that exploded millions of years ago, their expanding shells of gas now reduced to whispers of heat. This electromagnetic silence allows the 3I-ATLAS to function as a cosmic confessional, a place where the universe can finally reveal its most guarded secrets. The probe is no longer just a navigator. It is an ear pressed against the door of the infinite. It listens for the weakly interacting massive particles that are theorized to comprise the dark matter of the galaxy, seeking the infinitesimal thermal spikes that would signal their presence. It monitors the flux of the interstellar medium, measuring the pressure of the gas that exists between the stars without the interference of the solar wind's turbulence. The transition into this state of silence is a homecoming for the machine. In the noisy, crowded orbits of the inner planets, the 3I-ATLAS was a stranger, its capabilities suppressed by the sheer volume of the sun's output. Now, in the deep, it has found its natural habitat. The blue glow of its ion thruster is the only light in this electromagnetic desert, a small, steady flame that does not flicker. The craft moves forward, its sensors wide and hungry, drinking in the data of the deep. The maps of the solar system are now truly behind it, replaced by a new kind of map, a map of energy, frequency, and the fundamental vibrations of space itself. The voyage has moved beyond the physical and into the ethereal, where the only thing louder than the silence is the sound of discovery. In the absence of the sun's electromagnetic roar, the 3I-ATLAS begins to perceive a presence that has remained invisible to every eye that ever looked at the sky from the surface of the Earth. This presence is not composed of atoms, nor does it reflect, absorb, or emit a single photon of light. It is the dark matter, the silent architect of the cosmos, manifesting here as a localized density of weakly interacting massive particles, or WIMPs. For centuries, humanity observed the stars and realized they were moving too fast, held in their galactic orbits by a gravity that the visible matter could not account for. It was known that some hidden hand must be gripping the edges of the Milky Way, but that hand remained a mathematical ghost. Now, in the pristine environment of the outer solar system, the ghost begins to take on the weight of reality. The probe's calorimeters, cooled to the very edge of absolute zero, act as the most sensitive percussion instruments ever built. Within their crystalline lattice, the atoms sit nearly motionless, waiting for a disturbance. Suddenly, a single nucleus within the detector's core recoils with a violent microscopic energy. No light preceded this impact. No magnetic field heralded its arrival. A WIMP, a particle with the mass of a heavy atom but the ghost-like ability to pass through entire planets without leaving a trace, has finally struck a target. This is not a random occurrence, but the first note in a symphony of detection. As the 3I-ATLAS moves through the void, these impacts begin to form a pattern, a topography of the unseen. The data reveals that the vacuum is not a hollow void, but a dense structured scaffolding. This is the dark web that holds the visible universe in its embrace. The stars, the nebulae, and the planets are merely the luminous foam on the crest of a much deeper, darker ocean. The probe's sensors map this localized density, showing how the dark matter clusters and flows in long, invisible filaments. This scaffolding provides the gravitational framework upon which the Milky Way was built. Without this hidden architecture, the galaxy would have flown apart eons ago, its stars scattered like dust in a gale. The 3I-ATLAS is the first human instrument to touch this framework, measuring the precise gravitational pull of the invisible mass that makes up more than 85% of the matter in the universe. This localized map is a revelation. While astronomers on Earth must rely on the bending of light from distant galaxies to infer the presence of dark matter, the probe is measuring the substance directly in its own neighborhood. it finds that the dark matter is not a uniform fog, but a complex landscape of varying densities. There are wells of dark mass that exert a silent, powerful influence on the trajectory of the probe itself, minute deviations in its path that can only be explained by the presence of this invisible weight. The 3I-ATLAS records these fluctuations, translating the silence of the deep into a three-dimensional map of the galaxy's skeleton. The dark matter is no longer a mystery to be debated in the halls of academia. It is a physical presence, a tangible scaffolding that the probe is currently traversing. The narrative of the universe shifts. We are no longer the primary inhabitants of a world made of light and atoms. Instead, we are the minority, the small, bright exceptions in a universe dominated by this dark, silent majority. The scaffolding is everywhere, a cosmic lattice that connects the furthest reaches of space to the very heart of our solar system. The 3I-ATLAS, as it pushes deeper into the void, becomes a cartographer of the invisible, documenting the hidden currents of a dark ocean that has finally been forced to yield its secrets to a persistent blue-glowing spark of human intent. The mapping of this dark web reveals a profound truth about the nature of the vacuum. Space is not a stage upon which the drama of the stars is performed. Space itself is the lead actor, a dynamic and heavy substance that dictates the movement of everything within it. The probe's instruments detect the subtle ripples in this dark ocean, the gravitational waves and density fluctuations that tell the story of the galaxy's birth and evolution. It is a map of potential, a blueprint of the forces that will eventually determine the fate of every star in the sky. The 3I-ATLAS, by sensing the recoil of a single nucleus, has opened a window into a reality that is 5 times more substantial than the one we can see. As the craft continues its unceasing acceleration, the data streams back to Earth as a series of gravitational coordinates. Each point on the map represents a localized concentration of WIMPs, a knot in the dark web. This information provides the first true understanding of the galaxy's mass distribution, allowing scientists to see the Milky Way not as a collection of glowing dots, but as a solid, interconnected structure. The probe is moving through the very marrow of the cosmos, proving that the vacuum is the most crowded place in existence. The blue light of the ion thruster, though small, illuminates a path through this hidden architecture, a journey of discovery that has finally moved beyond the limits of light and into the heart of the dark. As the 3I-ATLAS pushes further into the lightless expanse, its infrared bolometers, shielded from the sun by the vast distance and the probe's own bulk, detect a phantom warmth. This is not the sharp, high-energy radiation of a burning sun, but a low-frequency thrum, a thermal signature emanating from a point merely 0.5 light-years away. In the grand ledger of the galaxy, this distance is a mere stone's throw, yet the object responsible for the heat has remained invisible to every optical telescope in human history. It is a brown dwarf, a substellar ghost that occupies the lonely territory between the largest of planets and the smallest of stars. This specific entity, a sibling in spirit to the cold wanderer known as Y0855-0714, serves as a grim reminder that the void is not an empty stage, but a crowded graveyard of celestial ambitions. The probe's sensors translate the faint infrared glow into a visual reconstruction of a world that never truly began. This object possesses a mass perhaps 30 or 40 times that of Jupiter, far too heavy to be classified as a planet, yet insufficient to ignite the sustained nuclear fusion of hydrogen that defines a true star. It is a failed sun, a sphere of primordial gas that collapsed under its own weight, but stalled at the threshold of brilliance. In its youth, it may have glowed with the dull red heat of a dying coal, fueled by the brief fusion of deuterium, but that era ended billions of years ago. Now it is a cooling ember, its surface temperature hovering near the freezing point of water, adrift in a permanent midnight. The 3I-ATLAS records the turbulent chemistry of the dwarf's atmosphere. Without the overpowering light of a nearby star to strip away its outer layers, the object has retained a complex stormy shroud. The sensors detect the presence of water ice clouds and thick banks of sulfide vapours swirling in a chaotic dance driven by the internal heat still leaking from its core. This is a world of eternal storms where no morning ever breaks. It is a lonely, cooling giant that represents a silent majority of the galactic population. For every star that burns with the ferocity of our sun, there are likely dozens of these substellar ghosts littering the darkness, invisible and forgotten. They are the hushed remains of the nebula's failed attempts at creation, the debris of a process that produces far more shadows than it does lights. The realization that such a massive object exists so close to our own solar system, yet remained hidden until a probe ventured into the deep, sends a ripple of reassessment through our understanding of the interstellar medium. We have long viewed the space between stars as a pristine vacuum, a bridge of nothingness connecting islands of matter. The data from the 3I-ATLAS shatters this illusion. The void is teeming with these dark travellers. They are the failed stars that the light of history has forgotten, objects that do not scream their presence across the electromagnetic spectrum but instead whisper in the long wavelength infrared. They are the hidden tenants of the galaxy, moving in slow, eccentric orbits that never bring them near the warmth of a true sun. As the probe glides past the gravitational influence of this brown dwarf, it measures the subtle warping of space-time caused by the object's mass. This is a physical encounter with the dark matter of a different sort, not the exotic particles mapped earlier, but the baryonic matter that simply lacks the energy to be seen. The dwarf acts as a gravitational lens, briefly distorting the light of more distant stars as it passes before them, a phenomenon the probe records with clinical precision. This encounter provides a new scale for the nothingness of space. If a mass 40 times that of Jupiter can hide within half a light year of our home, the sheer number of undetected bodies in the wider galaxy must be staggering. The 3I-ATLAS continues its journey, leaving the cooling giant behind. The blue light of its ion thruster is a stark contrast to the dim, reddish-purple hue of the dwarf's hidden face. The probe has documented a world that will never know a sunrise, a place where the laws of thermodynamics are the only masters. This encounter reinforces the mission's primary discovery. The universe is far more crowded and complex than our mathematics dared to suggest. The void is not a lack of things, but a container for everything that isn't bright enough to be noticed. The substellar ghosts are the silent witnesses to the galaxy's evolution, and the 3I-ATLAS is the first messenger to bring their story back into the light. The journey onward is no longer a search for empty space, but a careful navigation through a forest of invisible giants, each one a testament to the quiet, cold reality of a universe that does not need to shine to exist. The 3I-ATLAS arrives at the final rampart of the solar kingdom, a region of invisible turbulence located 120 astronomical units from the central star. Here, the sun's reach, which has dominated every kilometre of the journey thus far, encounters its first true resistance. For eons, the solar wind, a relentless torrent of protons and electrons, has screamed outward at supersonic velocities, carving a protective bubble in the fabric of the galaxy. This bubble, the heliosphere, has acted as a shield for the inner planets, deflecting the high-energy debris of the cosmos and providing a sanctuary for the development of life. But at this staggering distance, the momentum of the sun begins to falter. The wind slams into the cold, thin gas of the interstellar medium, creating a chaotic boundary known as the termination shock. The transition is not marked by a change in light, but by a profound physical sensation recorded by the probe's plasma wave instruments. The solar wind, which had been travelling at speeds of hundreds of kilometres per second, suddenly encounters a wall of pressure. In a violent deceleration, the wind drops to subsonic speeds. This is the cosmic equivalent of a river hitting the sea. The smooth, linear flow of the sun's influence breaks into turbulent eddies and swirling currents. As the kinetic energy of the particles is abruptly converted, the temperature of the surrounding plasma spikes. The 3I-ATLAS feels this surge of heat, a paradoxical warming in the heart of the deep freeze as it traverses the jagged edge of the sun's domain. Beyond the termination shock lies the Helios sheath, a region of compressed and scarred magnetic fields where the solar wind and the interstellar medium begin their final, slow-motion struggle for dominance. The probe moves through this thicket of charged particles, measuring the density of the interstellar gas, the ancient hydrogen and helium that has drifted through the galaxy since the dawn of time. This gas is the breath of the Milky Way, a cold and tenuous substance that exists between the stars, enriched by the heavy elements forged in the hearts of long-dead suns. To the 3I-ATLAS, this medium is a tangible force, a subtle drag against its hull that signals the end of the sun's absolute authority. The physical sensation of the sun's influence giving way is a moment of profound significance. For the first time since its launch in 2044, the craft is no longer moving through a medium defined by its home star. The magnetic field lines, which have been anchored to the sun's poles, begin to fray and snap, reconnecting with the vast galactic magnetic fields that weave through the interstellar void. The probe is crossing a threshold into the true deep, leaving behind the protective womb of the heliosphere. It is now entering the unshielded territory of the galaxy, where the full fury of cosmic rays and the high-energy remnants of nearby supernovae can strike without the sun's mediation. This transition highlights the fragile nature of our solar neighbourhood. The heliosphere is not a rigid fortress, but a flexible, pulsating membrane that expands and contracts in response to the solar cycle and the pressures of the surrounding space. As the 3I-ATLAS moves into the interstellar medium, it records the true scale of the cosmic tides. The sun, which once seemed like an all-powerful deity, is revealed to be a solitary traveller in a much larger and more dangerous ocean. The bubble that has protected Earth for billions of years is merely a localised pocket of calm in a galaxy that is often violent and indifferent. The narrative of the mission now shifts from a journey through the solar system to an exploration of the interstellar frontier. The probe has become a pioneer of the unshielded deep, a messenger sent to experience the raw, unfiltered reality of the Milky Way. Its sensors are now bombarded by particles that have travelled for thousands of light years, carrying the signatures of distant starbirths and the echoes of ancient cosmic collisions. The 3I-ATLAS stands at the gateway of the infinite, its blue ion exhaust a tiny flickering candle against the vast cold winds of the galaxy. In this region, the maps of the planets are replaced by the maps of the stars. The orientation of the craft is no longer determined by its distance from Jupiter or the Sun, but by its relationship to the galactic centre and the neighbouring stellar systems. The termination shock was the final border crossing, the point where the probe officially became an interstellar traveller. As it pushes past the 120 astronomical unit mark, the 3I-ATLAS leaves the last vestiges of home behind. It is now a resident of the interstellar medium, a silver needle threading its way through the cold, dark gas that connects all things. The sun is now just one star among billions, its kingdom a tiny, glowing spark in a universe that is suddenly terrifyingly large. The data streaming from the 3I-ATLAS forces a radical reassessment of the sun's sovereignty, shattering the long-held notion of the heliosphere as a static and impenetrable shield. For decades, the findings of Voyager 2, which crossed this threshold in 2018, suggested a relatively predictable boundary where the solar wind simply faded into the interstellar dark. However, the more sophisticated sensors of the new probe reveal a structure that is profoundly more delicate and reactive. The heliosphere is not the ironclad fortress of our earlier models. It is a thin, gossamer veil, a flickering candle held aloft in a galactic gale. The probe records how this boundary reacts with startling violence to the external pressures of the Milky Way, revealing a solar system that is not an isolated island, but a passenger in a turbulent and ancient sea. The 3I-ATLAS measures the immense pressure exerted by the local interstellar cloud, a region of gas and dust that the solar system has been traversing for several thousand years. This cloud is not a vacuum, but a heavy moving medium, the cooling remnant of ancient cataclysms. The probe's instruments detect the signatures of supernovae that occurred millions of years ago in the Scorpius-Centaurus Association, recording how the shock waves of these distant star deaths still ripple through the interstellar medium. These ripples buffet the sun's protective bubble like waves crashing against a fragile shoreline, causing the termination shock to heave and contract by millions of kilometers in a matter of days. The sun's kingdom is shown to be in a state of constant, desperate flux, struggling to maintain its shape against the crushing weight of galactic history. As the craft moves deeper into the transition zone, the count of galactic cosmic rays, high-energy particles accelerated to near-light speeds by distant black holes and exploding stars, surges with an intensity that the earlier Voyager missions could not fully map. The 3I-ATLAS reveals that the Sun's magnetic field, which acts as the primary filter for these lethal projectiles, is far more porous than previously believed. The data paints a picture of a solar system that is constantly being pierced by the radioactive debris of the galaxy. This realization brings a new perspective to the evolution of life on Earth. The very atoms of our biological history have been shaped by the fact that this bubble held just enough to prevent total sterilization, yet leaked enough to drive the mutations that fuel the slow dance of natural selection. The probe also records the turbulent tides of the interstellar wind, a stream of neutral hydrogen and helium atoms that flow through the solar system at 23 kilometers per second. The 3I-ATLAS observes that this wind does not arrive as a steady breeze, but in chaotic gusts, influenced by the gravitational wake of passing stars and the tangled magnetic filaments of the local galactic neighborhood. This wind erodes the outer edges of the heliosphere, stripping away the sun's influence and replacing it with the cold, raw chemistry of the deep. The probe detects traces of rare isotopes like iron-60, a substance that can only be forged in the hearts of dying stars. These particles, found embedded in the very fabric of the outer solar system, serve as physical evidence of past failures of the solar shield, moments in history when the sun's candle flickered so low that the dust of a nearby supernova rained directly onto the planets. This vulnerability is not a sign of weakness, but a testament to the scale of the environment. The 3I-ATLAS provides a localized map of these pressures, showing that our current era of relative stability is a fragile anomaly. The Sun is currently moving through a particularly dense patch of the interstellar medium, and the probe's data suggests that the bubble is being squeezed tighter than it has been in 10,000 years. The pressure of ancient star deaths is a tangible, measurable force that dictates the height of our atmosphere and the intensity of the radiation that reaches our world. The narrative of the heliosphere is thus rewritten from one of protection to one of participation. We are not merely observers of the galaxy, we are participants in its violent cycles of birth and death. The 3I-ATLAS, by measuring the fragility of the Sun's kingdom, has revealed that the solar system is a living part of the Milky Way's anatomy, reacting to every pulse and tremor of the wider universe. The blue light of the ion thruster continues to push the probe forward, but it does so with the understanding that the ground beneath it, the very vacuum itself, is a graveyard of ancient suns and a battlefield of competing forces. The journey is no longer a simple exit from a home, but a descent into the raw, unshielded history of the cosmos, where the only thing protecting the traveller is the thin, flickering light of a single star. The data streaming back from the 3I-ATLAS carries a weight that transcends mere telemetry, a burden of truth that threatens to extinguish the small, warm spark of human ego. As the probe drifts further into the unshielded deep, the reality it records is one of profound and absolute indifference. In this cold, mathematical framework, the laws of physics operate with a total disregard for the narratives we construct. To the vacuum of space, there is no distinction between the triumphant success of a multi-billion-dollar interstellar mission and the silent, drifting failure of a metal husk lost in the dark. Both are merely arrangements of atoms moving through a predetermined trajectory, governed by equations that do not recognize the concept of hope or the value of discovery. The universe does not celebrate the arrival of the 3I-ATLAS, nor would it mourn its destruction. It simply continues its ancient mechanical processes as it has done for 13.8 billion years. This realization brings with it a sense of existential vertigo, a dizzying awareness of the scale of our own insignificance. The 3I-ATLAS, the pinnacle of our engineering and the vessel of our highest aspirations, is reduced to a microscopic flicker in an eternal expanse. If the probe were to be struck by a stray fragment of primordial rock, or caught in the gravitational wake of a passing brown dwarf, the event would be as quiet and inconsequential as the collision of two dust motes in a cathedral. The stars would not dim, the expansion of the galaxy would not falter, and the dark matter scaffolding would remain unmoved. We are accustomed to being the protagonists of our own story, but the data from the deep reveals that we are not even footnotes in the ledger of the cosmos. The universe is a stage of such monumental proportions that the entire history of human civilization is equivalent to a single heartbeat in the life of a sun. The probe acts as a witness to a reality that does not require an observer to exist. For eons before the first biological organism crawled onto the dry land of Earth, the Trojan asteroids were locked in their silent dance, and the dark matter filaments were holding the galaxies in their embrace. The universe is not a performance put on for our benefit. It is a self-contained system of energy and matter that functions perfectly well in our absence. The 3I-ATLAS measures the density of the interstellar medium and the pressure of ancient star deaths, documenting a world that is fundamentally alien to the human experience. It is a world where time is measured in billions of years and distance is measured in the light years of a vacuum that never ends. In this context, the probe's journey is not a conquest, but a brief, fragile intrusion into a territory that has no name for us. The mathematical beauty of the cosmos is its most chilling feature. The same laws of gravity that allow the 3I-ATLAS to navigate the Lagrange points are the same laws that will eventually pull every star into the cold embrace of a black hole, or scatter them into the heat death of the universe. There is an elegance to the equations, a symmetry in the way particles interact, but it is an elegance born of necessity, not intent. The probe records the relentless march of entropy, the slow and inevitable degradation of energy that dictates the fate of all things. Whether the 3I-ATLAS continues to transmit its data for another century or falls silent tomorrow, the sum total of the universe's energy remains the same. The machine is a temporary pocket of order in a sea of increasing chaos, a tiny defiant rebellion against the second law of thermodynamics that will, in the end, be silenced like everything else. To look through the eyes of the probe is to see the universe stripped of its mythology. There are no gods in the termination shock, no destiny in the movement of the WIMPs, and no meaning in the thermal signature of a failed star. There is only the data, the cold, hard facts of mass, velocity, and radiation. This perspective forces a confrontation with the void that most of human history has sought to avoid. We have built our cities and our religions to shield ourselves from the knowledge of this silence, yet the 3I-ATLAS has been sent specifically to seek it out. It is a journey into the heart of the indifference, a mission to map the very thing that makes us feel small. The vertigo of this realization is not a sign of failure, but a mark of maturity. To understand the indifference of the universe is to finally see it clearly. The 3I-ATLAS is a lonely sentinel at the edge of the known, a silver needle threading its way through a mathematical tapestry of infinite complexity. It does not ask for permission to exist, and the universe does not offer any. The craft simply moves, its ion engine a small blue pulse of energy that serves as the only evidence of a species that once dared to ask why, in a universe that only answers with how. In this vast unshielded territory, the probe is a testament to the fact that we have finally reached a point where we can look into the abyss, and instead of flinching, begin to take its measure. The silence of the deep is no longer a threat, but a canvas, a cold, mathematical reality that we have finally summoned the courage to document, even if we are the only ones who will ever read the report. Against this backdrop of cosmic apathy, the existence of the 3I-ATLAS stands as a miracle of singular, focused intent. On a small, rocky planet orbiting a mundane yellow star, a collection of biological organisms emerged from the primordial soup, eventually looking upward with a question that the stars themselves could never formulate. These creatures, fragile and bound by the briefest of lifespans, did not merely accept the cold mechanics of their surroundings. Instead, they conceived of a way to project their consciousness across the light years. The construction of the probe was not just an engineering feat, it was a defiant assertion of will against the overwhelming silence of the vacuum. In the labs and clean rooms where the 3I-ATLAS was birthed, thousands of human minds collaborated to solve the equations of motion and the chemistry of ion propulsion, all to satisfy a curiosity that has no survival value in the traditional sense. The act of asking, "what if?" is the ultimate rebellion against a deterministic universe. By commanding the probe to ignore the gravity of Jupiter and steer instead into the absolute dark, humanity chose the difficult path over the convenient one. This decision was a pivot point in the history of the species, a moment where the pursuit of pure knowledge outweighed the desire for efficiency. In choosing the void over the giants, we asserted our role as the conscious observer. The universe, in all its vastness, is a blind and deaf machine until a mind interacts with it. Without the 3I-ATLAS, the brown dwarf would have continued its cooling in total anonymity, and the dark matter filaments would have remained a secret held by the shadows. By sending this silver needle into the deep, we have forced the universe to reveal itself, transforming a cold, mathematical framework into a narrative of discovery. The 3I-ATLAS is no longer a mere collection of metal, glass, and software. It has become a sophisticated extension of the human nervous system. Its sensors are our eyes, its calorimeters are our sense of touch, and its antennae are our ears, reaching out to name the nothingness. When the probe detects a surge in cosmic rays or a fluctuation in the density of WIMPs, it is the collective human mind that feels the pulse. This connection across billions of kilometers is a testament to the power of intent. We have effectively enlarged our reach, stretching our perception beyond the confines of our atmosphere to touch the very marrow of the galaxy. The probe is a sensory organ for a species that refuses to be limited by its biological boundaries, a way for us to exist in places where our bodies would be instantly unmade. This role as the observer is what gives the universe its meaning. To the vacuum, a star is just a fusion reaction. To us, it is a beacon of history and a forge of elements. To the dark matter, gravity is just a curvature of space-time. To us, it is the invisible scaffolding of our home. By documenting the fragility of the heliosphere and the presence of substellar ghosts, we give these phenomena a place in a story. We are the ones who provide the adjectives for the nouns of the cosmos. The 3I-ATLAS is the pen with which we write this story, a tool that allows us to translate the terrifying silence of the deep into the language of understanding. The very fact that we can track a needle of metal across the void, calculating its position to within a fraction of a degree, is a triumph of the spirit over the void. The significance of this mission lies in the realization that we are the only part of the universe that asks why it exists. The stars do not wonder about their origins, and the planets do not contemplate their end. We are the unique point where the universe has become aware of itself, and the 3I-ATLAS is the instrument of that awareness. Every bit of data that returns to Earth is a victory for consciousness, a small light reclaimed from the dark. By choosing to look at the nothingness instead of the giants, we have proven that the most important thing in the universe is not the mass of the stars or the scale of the galaxies, but the intent of the mind that seeks to understand them. As the probe continues its unceasing acceleration, it carries with it the hopes and the intellect of a world that refuses to be ignored by the infinite. We have given the void a name and a meaning, and in doing so, we have asserted our place in the cosmic order. The 3I-ATLAS is a monument to the idea that even in a universe of profound indifference, the act of observation is a sacred duty. We are the storytellers of the deep, the ones who turn the cold math into a legend of exploration. The journey is no longer just about a machine moving through space. It is about the persistence of a species that, when faced with an eternal expanse of shadow, decided to build a light and send it as far as it could possibly go. In this defiance, we find our true purpose, to be the eyes of the universe looking back at itself and finding wonder in the dark. The 3I-ATLAS is now a ghost of silver and gold, drifting through a territory where the very concept of a map has been rendered obsolete by the sheer scale of the surrounding vacuum. Its signal, a faint but steady pulse of binary logic, travels back toward the inner solar system, taking hours and then days to reach the listening arrays of its creators. Each packet of data is a precious artifact, a message from a future that humanity has only just begun to inhabit. The mission, which began as a daring deviation in the year 2044, has successfully rewritten the architecture of our celestial neighbourhood. We no longer look at the space between the planets as a hollow theatre. We see it now as a crowded, vibrant and terrifyingly complex ecosystem of dark matter filaments, substellar ghosts, and the turbulent remains of ancient star deaths. The probe is currently entering the inner fringes of the Oort cloud, a vast and icy shell of cometary nuclei that marks the true gravitational boundary of the Sun's influence. Here, the distances are measured in thousands of astronomical units, and the light of the Sun is so dim that it can no longer be distinguished from the other stars in the firmament. The 3I-ATLAS moves through this graveyard of ice with the same quiet dignity it maintained when it bypassed the amber storms of Jupiter. Its ion thruster, having exhausted the final reserves of its xenon propellant, has finally fallen silent. The blue glow that once served as a lonely candle in the dark has faded, leaving the craft to coast on the momentum of its years of unceasing acceleration. It is now a true interstellar traveller, a vessel of human intent that will continue to glide through the galaxy for millions of years, long after the hands that built it have returned to the dust. The legacy of this journey is a testament to the power of discovery. By choosing to look into the nothingness, we have found everything. We have learned that the heliosphere is a fragile and pulsating membrane, constantly buffeted by the winds of a violent galaxy. We have touched the invisible scaffolding of the Milky Way, measuring the weight of the dark matter that holds the stars in their orbits. We have witnessed the cooling remains of failed suns that litter the interstellar deep, proving that the universe is far more populated than our visual telescopes ever suggested. These revelations were not the result of a safe and predictable path. They were the fruits of a what-if scenario that dared to challenge the established protocols of exploration. The 3I-ATLAS has shown us that the greatest secrets are often hidden in the places where we were told nothing exists. As the final transmissions of the probe are recorded and archived, they form the foundation of a new cosmic narrative. This story is no longer one of a lonely planet isolated in a void, but of a conscious species that has finally begun to participate in the life of the galaxy. The 3I-ATLAS has served as our pioneer, a sensory organ that has stretched our understanding to the very edge of the infinite. It has taught us that while the universe may be indifferent to our presence, our ability to observe and name that indifference is what gives the cosmos its meaning. We have transformed the terrifying silence of the deep into a symphony of data, a record of our courage and our curiosity. The journey of the 3I-ATLAS is nearing its end, but the story it began is only in its opening chapters. The maps have been redrawn, the instruments have been refined, and the hunger for knowledge has only grown more intense. The void is no longer a place of fear, but a destination of infinite potential. We are the ones who give the darkness a voice, and we are the ones who will continue to push the boundaries of the known until every shadow has been measured and every failed star has been given a name. The mission of the 3I-ATLAS is a reminder that we are never truly lost as long as we continue to look upward and ask the questions that the universe itself cannot answer. To ensure that the story of the 3I-ATLAS and the secrets it uncovered are never lost to the silence, the exploration must continue. Every discovery made by this lonely probe is a step toward a deeper understanding of our place among the stars. To be a part of this ongoing journey, to witness the unfolding of the cosmic narrative and the revelation of the hidden truths of the universe, you're invited to join this community of observers. Subscribe to this channel and become a witness to the next chapter of our interstellar odyssey. Together we will continue to track the needles of metal across the void, giving meaning to the nothingness and ensuring that the light of human intent never flickers out in the great eternal expanse. The story of the 3I-ATLAS is our story, and the journey has only just begun.